Good day, everyone, and welcome to today's DevOps.com webinar. We're excited that you're here and that you've joined us. The topic of today's webinar is the top 5 AWS security mistakes and how to stop them before you lose data. My name is Mitch Ashley, and I'll serve as your host and moderator for the webinar. A few housekeeping items before we begin. First, this webinar is being recorded, and the recording and the slides will be available following the webinar on devops.com, as well as we'll be sending an email to everyone with links to get the content. We want questions. Our speaker loves questions, and we're happy to entertain those. So please put your questions into the GoToWebinar control panel and into the questions tab. Last but not least, we're awarding 3 $50 Amazon gift certificate cards at the end of today's webinar. So please hang around to find out if you won. Now let's move on to our topic, top 5 AWS security mistakes and how to stop them before you lose data. It's my great pleasure to introduce our speaker today, a friend and colleague, Rich Mogull. Rich is VP of Products at DisruptOps. He's also serves as an analyst and CEO of Securosis. Very knowledgeable about security and about the cloud, and I'll let Rich talk a little bit about that. So Rich, I'll hand the baton to you. Take her away.
Thanks, Mitchell. But most importantly, am I eligible for the gift cards at the end if I stay on? Otherwise, I'm out of here.
Friends and family cannot participate.
Ah, okay.
Sorry.
Never mind then. All right. I'd like to thank everybody for joining us today. As Mitchell said, my name is Rich Mogull. I've been doing cloud hands-on for just about 10 years now, and that is not an exaggeration. And the vast majority of that in Amazon. And so day to day, aside from managing product over at DisruptOps and kind of building some of these cloud automation tools, that actually spun out of the fact that I spent a lot of time and have spent a lot of time over the past years working directly with organizations, coming in, doing assessments on their AWS environments, a little bit of Azure, but mostly AWS. And what I have found is that there are some pretty consistent kinds of mistakes that I see across these environments. And this webinar is basically, let's take those, top 10 mistakes top 5 mistakes that I most commonly see when I go in and look at environments and talk about what causes those issues, how you can discover them, how you can potentially remediate them. So this isn't necessarily what you've seen in what you see based on the headlines. This is, this is the in the trenches, going into environments, doing these assessments, and what do I find? Now, one of the reasons I find this is that it's not that you can't be secure on Amazon. As a matter of fact, Amazon has just an incredible range of security tools to help us out. But the problem that we encounter, especially as you start growing your deployments, is a few things. I mean, first is the scale can be ridiculous. I was in conversations with some people today who have hundreds of Amazon accounts and are trying to figure out how to consistently apply controls across those. And those accounts are all segregated from each other, and all of these environments are segregated from each other. So kind of centrally managing that can be quite difficult. We also find that when you actually get into the weeds of Amazon, all the tools are there and everything defaults to secure, but there's a lot of different kinds of policy types and locations. So you have service control policies, IAM permission policies, IAM role trust policies, permission boundaries, resource policies, all of these, it's kind of that collection of all of those policies together that can end up leaving something exposed or not exposed. There's also complexity and inconsistency. Amazon internally, and look, this is not like saying they're doing anything wrong. It's the nature of cloud. They have a lot of different teams all building their own services, but they're not always consistent in the capabilities within those. So some will feed, different kinds of information to CloudWatch or CloudTrail, CloudWatch events, and others of those services will have differences in terms of what kind of resource restrictions can you put on your policies, what kind of conditionals are supported. Really incredibly wide range. And a lot of these things all look the same is the problem when you're looking at a policy as a policy as a policy, but how they will actually function are quite a bit different. And then lastly is visibility, particularly again, if you're, the segregation of Amazon is awesome. Regions are fully separated from each other. It is what we want from a security and a compliance perspective, but that does also make it harder for us to gain the visibility we need across all of that. And these are just some quick examples of the things that are challenge organizations. And one of the things I like to say is, look, when you move to cloud, there's always going to be a management cost associated with that. It is not necessarily more than what you're doing on premise, but you need to make the right decisions because you're either going to pay that price up front or you're going to pay that price later based on the decisions that you make about how you actually handle your implementation and how cloud native you are. Now, the top 5 that I picked today, and I think I actually threw an extra bonus one in there. These are the ones that I find predominantly in enterprise level assessments. This is the order that I look for them when I go into an organization and find them, because it just makes my life easier when I can just give the client a big old list of things that, I'm able to get done in the first, few hours of an assessment or even less, and then buy myself time to go do the rest of the assessment for the more nuanced issues that we find. And these are also the ones that are most likely to have a business impact when seen in a production environment. There's lots of these that I see in development environments where there's less sensitive things. I don't care as much about those. It's really whenever there's potential access to production data, and that's where these come into play. So I'm using a fair bit of judgment in how I picked these, but hopefully it'll make sense as we go through it. Again, as a reminder, pop those questions in. We are going to go with the answer all of those. I even have one of my coworkers, Mr. Mike Rothman here, who is going to help with answering some of those questions and posing those questions to me. All right, number 1. The first thing I look at, now actually the first thing I look at is what's your account architecture and how many different accounts do you have and how are those segregated. But if I'm looking at a single account, overprivileged identity and access management. And there's a lot of different sources for this. So the easier ones are too many base privileges given to a user group or role, often due to the use of multiple policies. I'll give you an example of this later where I'm actually going to do a live assessment on an environment. And as part of that, it's the intersection of 2 policies that are attached separately that creates the risk on that particular IAM user. But that's just getting started. The next level is not using constraining resources when you have your allow statements. Now, this is a little bit sketchier because, as I mentioned, sometimes you can't limit the resources someone has access to, and sometimes you can. The classic example here is the one we all talk about with S3, which we'll get to later as well. Oops, I just gave away the ending of my deck. But where somebody has read privileges or sync privileges, or even the list privileges, and then they have a resource of asterisk, a wildcard. And so they can look at everything versus putting those constraints in. And S3, I don't see that for as badly, but a lot of times in other areas around, particularly EC2 and such, or there's just not good use of those resource constraints. Then things start getting even more complex because we run into issues of poor management of what can use roles and what I call generally corrupt. When I go into production environments, I should only see users, groups, and roles that are in active use, and I should only see the trust policies listing specifically which individuals are allowed to use those roles. And almost every time without fail, I find that not managed well. I find unused roles in environments, unused admin roles, or even admin users in environments or groups with admin privileges that may not have any users in there. And why that's a problem is as an attacker coming in, when I'm trying to do privilege escalation, there's ranges of permissions I can use to take advantage of anything that's over permissioned in that environment. Not always, but sometimes. And so those are definitely exposures that you're leaving out there. And the other is if you're not good about who can actually assume those roles, particularly your users, never mind your instances, that again can lead to a variety of issues. And I'll go into the remediations for some of this in a minute. Then we get to incorrect use of conditionals or not using deny statements for backstops. You may know that everything is default deny in Amazon. And if you give somebody explicit allow statements, that determines what they can do. But if you don't have an explicit deny statement, somebody can add another policy that could expand those privileges. So by just putting a deny everything policy and attaching that to everyone, or not a deny everything, but adding deny policies for things you don't want that user group or role to be able to do, that will go ahead and serve as a great backstop for all those allow policies. Because the way Amazon works is default deny statements, explicit deny statements will override any allow statements, and then the allow statements beyond that that's basically the subset of what they can do. And then lastly is failing to properly utilize resource policies. So the resource policies, as we'll get into for things like S3 and Lambda functions, SNS topics, these are additional ways to go ahead and protect things that can be potentially opened up to users outside of your account. So IAM is where you manage all the users in your account and what they can do, or even cross-account IAM users. But if the resource-based policies are the things that are attached to those that S3 bucket, to that Lambda function, to that SNS topic, to determine who from the outside can take a look at those things. And so, this is just an example of when you give too many policies. This is one where if you give somebody the ability to apply a role to an instance, and that without any constraints because of that resource constraint, that means that that user can actually give an administrative role, if it's available into the account, to that instance, even if they're not allowed to use that administrative role, because this doesn't restrict them from giving the role to the instance. And if they can also log into that instance, then all they have to do is log in. That instance now has that admin role, and they have escalated their privileges. So that's just a really simple example of that kind of a scenario. So the impact of these things: privilege escalation, account abuse by administrators or others, or developers in your environment, data loss or destruction. We've seen that with overprivileged IAM leading to opening up S3 buckets or accessing things they shouldn't. And what I'm calling, we always talk about in the when you're looking at your CVEs for vulnerabilities, arbitrary code execution. This is arbitrary cloud execution. Once somebody can actually take advantage of some of these higher level roles, drop into them, it gives them basically full control over that particular environment. So how do we actually manage this one? And there's a lot of words on the slide. I'm only going to highlight a few things because we've got a bunch of these to get through today, but you want to be really clearly communicate your least privilege requirements and policies. Like, this is a management level issue, and if management won't back you up, you're not going to have any ability to control that, because you're going to get run roughshod by other developers and administrators and others who want to do things that they shouldn't be doing. So you've got to get those management policies in place. Then you can have different ones for development and production. You should be scanning and assessing for administrative level access. I'll give you an example later, not just full admin rights, but you can actually look for any opportunities for privilege escalation or any expanded rights within your account, or look for resources that, a lot of those resource asterisk kinds of permissions, especially in production accounts. Dev, we're a little bit more loosey-goosey as long as there's no sensitive data in there. One really good tool is to use the Access Advisor if you haven't seen that in the console, and that will show you the last time a permission was used by a given user group or role. That is now also available via API as of, I can't remember how many months ago, but less than a year ago, which means you can actually integrate that into your automations. Use those deny backstops, use different kinds of roles for admins, make them have like read only as the default, and then escalate privileges to make changes. I teach an advanced cloud security class, and that's one of the things we put in there. Use those resource constraints and be smart with your conditionals. I've seen some poorly written ones where it didn't work the way the organization thought they worked. Make sure you test those. And you can use the policy simulator to help you with that, as well as run your own manual testing. But really what it comes down to is constantly assessing and enable real-time your environments. And for production especially, enable real-time notifications for any IAM changes. You can do this through config. You can do this through CloudWatch events. There's a couple of different ways to do that, because production, you shouldn't have a lot of IAM changes, and that may indicate somebody's in there doing something that they shouldn't be. Any changes ideally should be running through your pipelines or should be part of a change a management window. Next, failure to use multi-factor authentication. I cannot tell you how often I see this. It blows me away how often I see this in production environments. First is not requiring it for console access. And you're just kind of, you're one step away from giving your cloud away, because the easiest way for an attacker to get in is to go ahead and compromise credentials, then go into that account, compromise a developer or an administrator system. The console is just straight up username and password. Without MFA, that means that the attacker doesn't even need to, kind of hijack a session of your user. They can run that whenever they want. Now, level 2, though, is not require it for command line interface or API access. We'll go more why that's such a big issue, but if you require for the console, but that user has full admin privileges on via the command line, via API, like, okay, they are still now down to static credentials unless you're good with your federation, and federation can help with there. But related to federation is relying only on MFA at the identity provider level and not enforcing it as well at the cloud level. This is complicated because sometimes that is the right decision. And what I mean is, if you log into your Ping, your Okta, your Azure Active Directory, and you require MFA there, then when that user connects into the cloud account, it doesn't force MFA on the Amazon side. This is more of a diligence of management issue. If you're really sure your identity provider works well, you may not need that as much. But if you, a lot of places I go, they're really inconsistent about enforcing MFA on the identity provider side, and it's very easy for a user to actually get up to, close to full admin privileges based on the user group or role in their Active Directory or whatever it is, and then that leads to an exposure over on the Amazon side. So, impact, credential theft, accidental credential exposure, and again, that arbitrary cloud execution. It just overly opens stuff up for the bad guys to be able to take those credentials and do things someplace else with them. So how do you fix this? Require for the console logins for sure, and require MFA for the command line and the API level. So this is just basically an example of a policy that doesn't allow anything related to other than a few exceptions, unless they have their MFA present. And then for that identity provider issue, you can pass that stuff over, but that can be difficult to do because it has to be a custom attribute. So going into details of that is beyond the scope of kind of what we're doing. That would be like a whole webinar itself to show you how to do that. It is possible. It does take more work. Next up, not enabling monitoring. This blows me away again when I see this, but very frequently encounter. One is not enabling CloudTrail for all regions in all accounts. I mean, this is just like, you have to do it. You suck up the costs. It's not even all that expensive depending on how complicated it is. And by enabling CloudTrail, I mean, just because you log into the console and you see events in CloudTrail, that doesn't mean it's turned on. That's only 7 days of events. I went into an environment and the account owner was like, well, it's turned on because I can see the events. I go, no, you're not recording those anywhere. You're not sending those to a SIM. You have no alerting, and you can only see them in the console. Like, that's just not the right answer. Next is sending CloudTrail to CloudWatch. This is super important because if you don't, and you just save your CloudTrail to S3, you are looking at a minimum of a 10 to 20 minute delay on when something occurred to when you could potentially receive a notification. Most of the tools today, the Splunks and stuff of the world, don't rely on that old S3 integration as the main way they pull logs. And to enable everything else, you have to feed CloudTrail to CloudWatch. And it can actually get a little complicated because if you're building alerting into all of your accounts, you need to enable that with a separate trail in every region to get around some of the segregation issues. For example, if you set an organization cloud trail and then you set some CloudWatch events to alarm off of that natively within Amazon, those won't actually trigger in that organization trail. You still have to have trails in all the other regions to enable this. Then we have not turning on guard duty, trusted advisor, VPC flow logs. Those are really depend on what your accounts are, whether or not you need them. But a lot of places, they don't really have a pattern for when they want to turn those on. Another one is not doing anything with the logs or not enabling security alerts, level 4 and 5 there. I once went in and did an assessment. They had all the alerts set up and had all the notifications set up. And I went to the SNS topic, looked for any subscriptions, and there weren't any. I said, why do you guys have this set up? And they go, well, we know what to do, but nobody in security is ready, because this was the development team that brought me in. Nobody in security has an IR process around this, so they won't tell us where to send those alerts. Needless to say, bit of a governance issue going on over there. But kudos on it was the development team, the app team, that was doing everything right. And in that case, it was actually security, see no evil, because they weren't ready to deal with cloud. And then lack of central logging and alert management. As you scale and you scope out, you just can't deal with this across all of your accounts. So what happens? Well, you don't have visibility, or your logs may be slower and your alerts can happen 20 minutes later, which is not fast enough because attacks are pretty automated. I run attack demos and I have an incident response simulator that runs in 30 seconds. It fully compromises an account. Never mind waiting 20 minutes to figure out what happened. You might have unidentified security events. You're going to miss things. You're not going to have good forensics. You're going to be slow to respond to incidents. And to be honest, you're just going to fail audits for anything that's production, for those of you that are regulated. So how do we fix this? The organization trail is great when you can use it. It'll scale up to a certain point before it falls over due to size. But I found that one of the nice things about the org trail is that also makes it impossible to turn off, or not impossible, very difficult to turn off CloudTrail in all of the sub accounts. You actually have to fully disconnect the account from the organization to be able to turn those trails off. Always send a CloudWatch, make sure you centralize, use service control policies to prevent disabling logs. And we're not going to go too much into SCPs, but that's a really simple one, to basically not allow disable delete CloudTrail or changing of or any of the CloudTrail modifications once you get it set up. Centralize your security alerts, make sure you have requirements around guard duty, trusted advisor, and be good about collecting your CloudWatch events across regions. This can be hard because things like guard duty do not centralize across regions. I had somebody tell me once, oh, we centralize everything in Security Hub across all of our regions and all of our accounts. And I'm like, you can't do that. You can consolidate across accounts, but it's still locked into that one region. And then you have to actually forward those events out to wherever else you're going to go. And then keep assessing for compliance. These things get turned off sometimes or not used. Just make sure you're constantly watching it. And this screenshot's just a quick example. Apply trail to all regions. Yes. Apply trail to my organization. Yes, if you're using your organization. And that alone right there will wipe out a lot of your risk. It just stuns me that I don't see this every single time I go in. I get it if the organization trail's not there, because not everybody uses organizations, but you should really make sure you have some kind of centralized cloud trail across all of your regions. All right, we're moving pretty quick and getting through these things. Next up is expose ports 22 or 3389. I get it. You are thinking to yourself, what kind of an idiot would do that? And yet I see it on every single assessment I go into. I am not sure I've ever had an assessment where I didn't find accidentally exposed port 22 or 3389 in an environment. And it's for a lot of reasons. Now, it doesn't mean necessarily that the server was exposed, but I am seeing at least the security groups there. And then I'd say, almost 100% of the time, and I'd say 70 to 80% of the time, there's something exposed behind that. And why? Well, there's the convenience factor. The Amazon console, for those of you who've been doing this for a while, if you launch an instance out of the console, it used to default the security group to no access. Now it defaults those launch wizard security groups to port 22 open to the internet. And that's one thing that I run into all the time is I see those launch wizards, and I actually wrote a scanner to kind of find those in environments because it's just such a common issue. Or convenience. Developers, admins, they get a little bit lazy sometimes and they just kind of open it up. Sometimes it's because they opened it up in development and then that account became production. Sometimes it's just accidental, temporary groups, and sometimes it's a result of an attack. I've been lucky, none of my clients have I seen it where that was opened as an attack, but I think one of the worst ones I saw, I went into an environment, it was like their Puppet server, and I went to the admin, I'm like, why is this exposed? And he goes, that wasn't there a month ago. Like somebody had gone through in that past month, and they didn't have any alarming or alerting in their environment, which comes back to our last one, to tell them anytime something port 22 was exposed to the internet. And if that's built into Trusted Advisor, it's built into Inspector, lots of different things. And so you can end up with compromised servers or containers. This is also one of the easier ways to pivot to the metadata service. That's been the news a lot with the Cap1 breach and others. That was a server-side request forgery, but there's ways we can kind of protect against the SSRF. It's hard, but it's doable. But if somebody actually gets into the instance, then it's very, very difficult to go ahead and proxy that properly in a way that the bad guys can't get around. This is also a great way for them to get persistence. If they can get in, maybe pull some credentials out, do stuff on the outside, then go back in if those credentials rotate or get, or you don't do the cleanup in your account. And lastly is loss of jump box and management servers. This one org, port 22, Puppet server, exposed to the internet for at least a month, and that was not a fully patched system as well. And so that combination, kind of got ugly, and they made the decision to just burn that instance down and recreate it someplace else because they were basically could not be relied on to know that it was secure. So how do you do this? Well, continuous assessment. Trusted Advisor will do this for you. It actually will give you those alerts. You just have to make sure you use it and capture the CloudWatch events from it. Amazon Inspector added network capabilities recently, and that can pull it up. You can compile this into Security Hub as well. I kind of left that one there. And then there's third-party tools. So this is us, DisruptOps. We look for this thing. In our case, we'll actually not only look at it for open 000 access, which is everything on the internet. We can look for any internet routable IP addresses and actually compare that to a known list of approved addresses. So we can find openings like you would see here. I'm guaranteeing one of those is probably a coffee shop someplace, mostly because that's my personal test account and I opened up a security group from a coffee shop. So kind of gives it away when you know the answer. The next one I run into is flat security groups. That's a term that I came up with kind of a while ago to describe security groups that look like flat networks. And the basic, version of this, it's like the default security group in every VPC, which allows all access for anything within that security group. Again, that was not always the default in AWS. They enabled that to reduce their support calls because people didn't know how security groups worked. I don't fully blame Amazon for that one. But the problem with that is that once you allow any access within a security group, that really starts to break some of that compartmentalization. We'll go over the impact in a moment. There's also any rules between security groups. I had one of these. It was for a software vendor who was doing a hosted thing where they were hosting their product for their customers. And it was fascinating because they had all these any groups between the application tiers. I said, well, that should only be the allowed ports and protocols. And they said, we can't. The developers won't tell us what ports and protocols they're actually using in case they want to change things. They don't want us to lock things out. I'm like, well, okay, you've got a governance issue at that point. I can't fix that part of it. And then things can be any rules or wide port range rules between large networks. If I go into your Amazon environment and I see you've set like /8 rules, which is, class A networks practically, I mean, big networks, then that usually indicates to me that you've got things opened up more than it should be because your restrictions should be pretty tight. This tier talks to this tier, talks to this tier, and only over the allowed ports and protocols. And if you can do that, you're in great shape. As a friend of mine used to say, he and I used to present to Chris Hoff at the RSA conference together every year. If you are bad at your network security on premise, you will be pleasantly surprised at how little changes when you move to cloud. And if you treat your cloud network like your on-premise network and open all this stuff up, then attackers are going to have a field day, and it really becomes no different than what we've dealt with in our data centers. Because then they can port scan, they can do network attacks, they can just move all over your environment. And if you design things really nice and constrained, you'll be in good shape. This is exactly kind of the same as our last example where you want to be able to do continuous assessment. The problem is there's nothing built into Amazon that will look for those kinds of mistakes. So, excuse me, you need to go ahead and either build your own or use third-party tools for that. Now, if you want an example of an open source tool that can help you with this, take a look at one called Cloud Mapper, as well as commercial tools. I'll give you a little demo of the kinds of stuff that we can do. All right, now let's move on to Amazon S3. So I used to say, I can't believe people leave their buckets public because it's really easy to turn that off and they default to secure. And then I realized, you know what? That's because I've been using S3 for 10 years. Well, at the time, maybe it was 8 years. And it actually is more hard than it should be. You've got to deal with public bucket access control lists or overly wide bucket policies where you can open things up to the internet or parts of the internet or users in different ways. You can have object ACLs. This is like a dirty secret. You can actually change the access of an individual object. But the problem is the way Amazon's set up, if you have a large number of objects in your buckets, it's really hard to find those because the number of API calls you need to pull all those public ACLs for all of those ACLs for all of those objects is going to exhaust your service limits. There's really not great answers there. So everybody mostly just focuses on the buckets. There's cores. You can actually get exposure via cores when you're doing website hosting stuff. And then more subtle ones. If there's a thing called the CloudFront origin access identity, which allows CloudFront to access a non-public S3 bucket. But if that CloudFront is public, all the data in that S3 bucket is public. And maybe you mean for it to do that, but on occasion, this is not one of the ones I find all the time, but on occasion, people look at the buckets and say the bucket is private, but then somebody else had overlaid the overlaid CloudFront in front of it, and then that made that content public. And then lastly, you have a compromised server or server-side request forgery. It doesn't need to be the full, necessarily the full API the full metadata service kind of abuse like we saw at the Capital One breach. You could just sometimes access that bucket data directly via SSRF, depending on how you have things configured. And so that's obviously another one you need to worry about. So the real problem is there's like 5 to 7 ways, depending on how you count, S3 data is potentially public. Not all of those are intuitive, and there's quite a few that are edge cases. That said, it's usually the obvious ones that I find, where somebody just used the ACL or the bucket policy to make something public. And we all know the impact of this one. Data leaks, compliance violations, and ending up in the headlines. I just did a screenshot yesterday when I was building this deck or finishing up the deck of, AWS S3 data exposed. And it's just headline after headline. We've all seen these. And to be honest, some of these are probably did not result in losses. And they were more the result of security researchers looking at stuff, but that matters. And that's still going to count as a breach if you don't know intuitively where that goes and where that data potentially went. So how do you fix it? Well, a very coarse option that Amazon added recently is the S3 public access settings. So this will lock down your ACLs and your bucket policies, and you can do it on an account or a per bucket level. Now, if you have an account like a dev account where you never, ever, ever want anything public, that's pretty good and easy to set. When you start wanting granularity, then things get complicated again because you got to set it on per bucket. You have to send it on per bucket levels and then make sure you get everything configured properly. Trusted Advisor can help you identify some of these. Doesn't look for all of the edge cases, but pretty decent. And even the S3 console will look for it. You can also run config rules against public buckets to try and identify those and send alerts. Again, won't find all of the edge cases, but can help. And then you get more into building your own. Oh, and by the way, if you use config rules or Trusted Advisor, that actually uses a more advanced thing called Zelkova that you don't have access to unless you're part of a preview program or you're using it through one of these tools that does all sorts of artificial reasoning AI stuff to actually determine if something is public or not, which can help you a lot because manually assessing those can be difficult. So Zelkova is good to help catch some of those edge cases. However, it only works with the bucket policies. And then there's third-party assessment tools and third-party guardrail tools, ones that can automatically close those buckets. I have seen many organizations build their own guardrails for S3, although the new public access settings are reducing the need for that unless you have to have more nuance to how you're going ahead and doing things. All right, so that's it. Those are the top 5 areas. We have IAM, multi-factor authentication, exposed admin ports, improper logging, monitoring, and alerting, improper use of S3, and I'm missing one as I'm doing my count here, but that's okay. So I want to spend a little bit of time talking about actually
Hey,
how
Rich,
we help. Yeah, Mike.
before we go into that, I guess I want to talk maybe for 2 minutes just on really what, kind of the attack surface and the threat surface is in the cloud, right? Because both of us have been 20 plus years security professionals. We see everybody really focused and consumed by sophisticated attackers and by kind of advanced malware and all of kind of the space alien type stuff that we've been seeing over the last 4 or 5 years to compromise on-prem type stuff, compromise devices, and then move laterally and all that kind of stuff. When we move into the cloud, what strikes me in terms of your top 5 mistakes is that none of them are overly complicated. Right? None of them, kind of are like, oh my goodness, this person has to have a PhD in hacking people's stuff in order to perpetrate this attack. And I think that's, a worthwhile kind of thing to riff on for, again, just a minute or two in terms of simplicity versus sophistication relative to the attack surface in cloud.
Yeah, I think that's a great point, and it's something that I've been saying for years now, which is simple doesn't scale. And a lot of people like to knock, all right, this org got breached because they didn't follow, because they left the public, bucket public, or they left IAM over permissioned or something else. It's fine when you're dealing with your own tiny little AWS account or small environments. It's manageable. But when you're dealing with is some of, there's organizations with hundreds and thousands of Amazon accounts and application stacks and everything all over the place. And managing those consistently at scale is where things get to be incredibly difficult. And that goes back to what I was saying earlier about that management cost, because I'll go into orgs and even before any tools exist on the market, I'm like, okay, this is what you need to do. This is how you build your policies and your automation. This is why you want to segregate your environments. And they didn't want to do that because the management overhead was too much. But then it became harder for them to actually find and fix, these simpler mistakes, just because the complexity of doing that at scale is just absolutely ridiculous. So yeah, I mean, it's the usual. The attacker only needs to be right once, and you need to be right every time. But that doesn't change. I mean, it's true. You've got little wiggle room.
Right. And I think the point that we really want to highlight here is that when you're dealing with, kind of more traditional security on-prem devices, lateral movement, all of that kind of stuff, then we're dealing typically with a more sophisticated attack where the sophistication and complexity happens when we start using cloud. And I'll make the assumption that, we're talking about solid cloud architecture with proper account structure, and a lot of the best practices that we certainly have espoused for many years. It's really about doing those fairly simple things at scale, right? When you start getting to hundreds, if not multiple hundreds of accounts, making and enforcing a consistent set of policies for these best practices is really a challenge, right? And I think that's probably a pretty good segue to the next section.
Yep. So this is where I want to kind of jump in and show you at least how we manage this with our concept of automated guardrails. And so this is all about providing that continuous control for your environments, where you're constantly able to assess for these conditions across multiple accounts, multiple regions, everything you need. You're able to go ahead and automate your remediations, and you're also able to do so in a way that has nuance to it. And I think this is one of the advantages over building your own, is the ability to filter for different environments and integrate things like tags and such, and do it all from a centralized console. And so DisruptOps is a software as a service platform that actually goes ahead and enables this automation. Instead of talking about it, let me go ahead and swap over and I'll show you what we look like. So I'm going to give you a real quick demo of what I think are some of the kind of cooler, more nuanced situations here. Mike, am I showing on the screen well? All right, Mike's still on.
You are. I did. I was a little slow on my mute finger, but.
All right, so we give visibility into the environment. We've got 3 accounts hooked up here, but I'm going to go ahead and just show you how we actually can assess and remediate one of these things. So I set up a demo environment and I'm going to go into our CIS benchmarks policy. I added a couple of things, and you can see I have all sorts of issues here. Now this is actually one of my personal demo accounts, so of course it's going to have a lot of issues because I make a lot of issues. And we talked about some of these. One of the ones that I like to talk about is the high-risk IAM permissions. So I mentioned earlier how it can be that combination of policies, and that's one of those things that's hard to look at, and that you have to assess those multiple different policies that might be attached to a single entity. And so in this case here, unless somebody accidentally fixed it, there we go. Hacker has one risky privilege. I obviously kind of probably made it a little too obvious by calling it hacker. And if I look at the actual detail associated with this one, then I can go through and see what the user policies are and see what the permissions are that are associated with that. So for EC2, that user has access, and drill down a little bit here. So they have run instances, associate IAM roles. So they can actually attach IAM roles potentially to this instance. Well, okay, well, that only works if they have a privilege called pass role that's associated with that. And oops, there's IAM. It's a whole separate policy. And it was the combination of these 2 policies together that actually allows the user to pass any arbitrary role to that instance. So then all they need to do is be able to log into that instance and they can escalate their privileges. Nice thing here, take action. I can completely quarantine that user or do a minimal quarantine policy, which would just take out that pass role statement. But in this case, I'm going to go ahead and do a complete quarantine on that user, move them into a quarantine user group, and then that issue is going to be remediated and resolved. I don't need to worry about it anymore. Now, by moving it into a quarantine group, that keeps all of the existing permissions associated with that user. And that's why I recommended using denies as a backstop instead of just deleting the policies, because you can go through and you can actually look and see what access did they have and why did they have that. So we'll go back over here into our demos, and we can do similar things as well. And you see that's now remediated for internet exposed admin servers. So in this case, ports 22 and 3389, I'll pull up one of those issues here, and that has access from everything, and it's in a test account. So I know it's one I can go ahead and remediate. And I'll make sure, let's see, what are the tags here? Tagged as test 2. So I'm going to assume I can mess with that one without breaking anything. I'm going to restrict access. Let me go ahead and add an IP range here. Probably bigger than it should be, and I could add more IP ranges, and I'm going to go ahead and run that one, and it's just going to go ahead and automatically close and remediate that particular issue. So that's an example of how you can actually go ahead and manage these issues across your different environments and look at things like IAM that spans different policies, but it's really that visibility that into all of your accounts that becomes just so critical to manage these kinds of things at scale. And look, I'd love it if you went with us, but if you need to build your own. I don't care. This is the only way to solve these problems, is with some degree of automation, with continuously assessing your environments and then having the ability to go through and actually remediate things either automatically or instantly notifying a user or an administrator so that they can go ahead and remediate that issue in that environment before the bad guys are able to do something with it. So what do you think, Mike? Anything else we need to talk about here? Otherwise, just
I do. Isn't this, kind of hard? Don't I have to? Isn't there a lot of setup and installing a whole mess of software and all of that kind of stuff to, get going with something?
Good question. So we're a SaaS platform. To provision an account, all you got to do is pop in an account ID here, give it a name, add the account, and then click a link. You have to be logged into your actual Amazon account. I'm not right now, but that'll launch a CloudFormation template that will load up with all the settings. You run that, we're connected in, good to go. So it's about, I don't know, I'd like to say it's one click. It's like 5 clicks, depending on how many if you need to copy paste or if you're just going to open in a new tab. Now I'm not logged in, so it's going to error out in this particular browser and require me to log in, but it's that easy, real fast, quick, and simple.
And I think that's really one of the key points that we want to highlight. Yes, you absolutely can do this yourself, and I suspect we'll be talking about that a little bit more in the Q&A. But it really is about kind of positioning and ensuring that you can enforce a lot of these best practices at scale continuously. Right, that's really kind of the key, because as we've seen, even very, very capable organizations will make mistakes, and not having somebody there to make sure that you're not, or something there to make sure that you're not driving off the road, so to speak, is pretty important. Again, as these things scale up, 1, 2 accounts, 10 accounts, manageable, 100 accounts starts to get really, really difficult to do.
Yep. So I think we've got some questions that we can roll into here for our last 5 to 10 minutes before we're supposed to finish up.
Yeah, we sure do. Thank you very much.
Hand off to Mitch.
Yeah, thank you, Rich. Thank you, Mike. Okay, let's jump into this here. Some really good questions. Let's start talking about automation. Not everyone is comfortable with automation. Sometimes it's even a little bit scary to get into. How can they do automation without running the risk of taking down their applications? What's some suggestions you have for getting started?
Yeah, I mean, obviously we've got some bias here towards, our capabilities, but if you're going to do this yourself, there's some, some general tips. First of all, when you're getting started, do things in assessment mode first and make sure you really understand, we have kind of like a drive run feature that we use in our environments. And I think you absolutely need to run assessment before you go ahead and turn on the automation. I have an example I use in a training class. We actually give the code to the students to find all that port 22 open to the internet stuff, and it assesses, and then the human has to make the decision on whether or not to remediate that. And as you tune that over time, that will get you more comfortable until you can go into that full automation mode. Particularly, you might put in some, kind of alarming of, if I'm going to make more than N number of changes, then go ahead and actually flag an alarm instead of just automatically doing that one, because maybe we're going to make too big a change into our environment. It also means you've got to work with your teams. So you have to work with your application teams, your developers, to understand what they're doing and how they do it. There's big differences between a production environment coming out of a continuous integration pipeline where, you got change meetings and release managers so that you're actually able to really control what those changes are, versus some of these more free-form developer accounts, or what we call sandbox environments, or I call them playground environments, where the developers are allowed to do a lot more. And so you want to make sure you're applying the rules differently across those different environments, because that also will keep you out of trouble. Because I've seen issues where people lock down like dev accounts too much. And look, if that dev account doesn't have production data, if that, the risk exposure is low, there are some more coarse guardrails you can put in place, like don't allow any internet access at all. That's the kind of guardrail I totally put on a developer account, or as best you can. There's some AWS services that can be tough to go ahead and enforce with. But then in your production environments, that should allow internet access, but only the exact things that that you want to go ahead and enable.
The other thing
Go ahead, Mike.
I'd add to that, Rich, is you kind of alluded to that right in the beginning, but it's a concept that we kind of teach and have been, again, espousing at Securosis for many years. It's this idea of trustable automation. Right.
Yep.
And it's not just, again, we have this whole big cloud security maturity model that we've built out. And obviously that has to do with embracing automation really at all levels of how you manage your cloud, security being certainly a key aspect of that. But it really is about having a repeatable process that allows you to build trust in the automations that you are implementing. So that means, as you mentioned, right, obviously using assessment mode up front, and then maybe even a human triggered mode. So, it's like press this button if you want to make this change before it actually happens, doing things that are lower profile, lower risk, that don't, kind of impact customers and or maybe it's making some changes to auto scale groups, or moving things out of the line of fire and then having them rebuild with auto scale groups if you do think some things are compromised. So, really kind of incrementally stepping towards those more sophisticated automations, which again allows not just you, but the team to build trust in how you're going to operate this environment, and having that as a repeatable process, something that is acceptable and understood within both the, certainly the operational team as well as the security team. Again, just critical success factors to making your automation strategy work.
Yeah, absolutely.
A question about this I have for you guys is, are there other things we talked about building up the trust through that process, Mike? Are there other things outside of that you want to add to this, so that over time, you're kind of watching the watcher, you're checking security through vulnerability scanners, port scanners, other things that either may snuck in through the automation or may still be happening manually? What are the other things that we should add to that? Any thoughts on that?
Can you repeat the end of that one, Mitchell? I lost it.
Yeah, no, sorry. I'm really just was interested in addition to the automation, are there other things that you should do as a secondary check?
Oh, yeah. So there's a couple of levels of this. My favorite, the way I like to say it is cloud security starts with architecture and ends with automation. And there's a lot of hardening architectural things that you can do up front before you even get to dealing with your guardrails and such. Making sure that you're making proper use of the tools that Amazon gives you. Because when you do that, you really are reducing, in a lot of ways, your attack surface. Again, once you start scaling up, that's where that starts to fall apart. But by the same token, I see, a lot of places where they come in and, they did a lot of experimentation and they made something production, and they didn't really think through the full architecture and take advantage of segregating those security groups and, being good about their IAM from the start. And those are the kinds of things. It's easier to get that done up front versus trying to go ahead and deal with it after the fact. And then there's always going to be those manual aspects of things. You're still always going to have to do some, degree of, human eyeball assessments or looking at particular issues so that, again, in our case here, yeah, I could go ahead and take this particular guardrail. I've got S3 up, and I could turn it on to automatically remediate all of those issues. But that's not always the right answer. As much as I love automation, love all the complete guardrails, it's all about making sure you filter down to your right environments so that, you could say, ignore certain tags or those kinds of things. And then those are the ones that the humans can focus on. There's no way to get the humans out of the process completely. That's for sure.
Great. Good. Thank you for answering that. Next question. Capital One, financial institutions, we all know we're pretty on the leading edge of being sophisticated in terms of their cybersecurity. So if they can't protect their cloud resources, do the rest of us have a chance? What are your thoughts about that?
Yeah, I mean, look, the Cap One breach was interesting on a couple of levels. They have some of the best cloud security people out there. They have released open source tools, like they know their stuff, but sometimes stuff slips through the crack, and there's kind of governance and visibility issues. And the mistakes that we're running on public info. We don't really know exactly everything that happened. The only thing that we can trust is what was in the Department of Justice complaint that was filed, because that's a legal document, so we know whatever's in there is likely true. Based on that, it looks like there were, some privileges and other things that weren't necessarily managed correctly. Again, building comprehensive visibility and automation, I think, is and having good policies in place so people know what is allowed and what is not allowed. Those are the kinds of things that can help us avoid those kinds of issues. But the best companies in the world always have security breaches. And like Cap One, first couple of things. One is we don't even know if that data was used maliciously. It sounds like the person who grabbed it was in over her head. Number two is once they were able to detect that something was going on, their IR process closed that down really quickly, and they handed that individual over to the FBI on a platter because of the amount of logging and centralization. So they made some mistake, yeah, but they did a lot right. And that really, I think, in the long term will go to their favor in reducing the overall business impact of that breach.
Yeah, and I think the key aspect there to just reiterate in a little bit more of a pithy statement is, small error, major breach, right? And that was kind of what I was getting at before about, kind of the whole simplicity and doing this simple stuff at scale being so complicated, as much of an oxymoron as that is, in the cloud. This is just, again, a very high profile example where a pretty straightforward, fairly simple issue, resulted in, pretty significant problem for the company. So it is about doing the simple things consistently and effectively and continuously as you move into the cloud, where when we're protecting our data center, again, the attack surface, the threatscape, and, the adversaries that we're dealing with tend to be quite a bit different.
Yeah, and in their case, it was actually the combination of two issues that caused it. So it wasn't like they made one simple mistake. It was two, and maybe three, depending on how you count. Again, all known kind of potential issues that combined together to cause it. And that's why, again, that more comprehensiveness, that being able to look across all of those things, because that bucket that was exposed, that was not a public bucket. That was restricted, but the IAM privileges were too wide, and that was combined with another flaw someplace else in terms of an actual server flaw and possibly a security group flaw. So it's like that combination, which is again why that gaining more of that visibility and having a bigger set of rules that you're able to look at becomes so important.
Very good. Reminds me of the old saying, there's two kinds of companies, those that will be breached and those that already have but don't know it.
That's right.
Yeah. It's true, and it's true for all of us. What was it, Mike? We did a blog post on the Securosis side, over 10 years ago, saying we will be breached at some point.
Yes.
And I think we have been, and we just don't know it because I haven't found anything yet, but I'm sure we have.
Fall into the second category. Okay, let's jump to another question. If I wanted to implement my own S3 guardrail, what would I need to do? And this follow-up question is, can I do that across all of my accounts and regions?
Yeah, so there's no centralized way to do it across all of your accounts. There's not that capability in there. Within a given account you have the ability to lock off all public S3. But remember, once you turn that setting on, you can't have any public S3 buckets, which depending on what you're doing in that account may be problematic. We use public S3 buckets for single page applications. So there's a lot of, which is where it's basically we're hosting a website in an S3 bucket, which is a very common deployment scenario. So that setting won't necessarily work unless you're really, really sure nothing in that account should ever be exposed. The next is to go into basically that same level of control over your buckets, but then you also want to back this up. You're going to need to go ahead and build a guardrail looking for those CloudFront origin identities, which again, you can scan for those. It's not built in, but you can write a Lambda function to do that. And so it's kind of that combination of that you need to use. So the easy answer is no, there's no way short of using third-party tools to go ahead and be able to manage that across all of your accounts. And then within your accounts, you can lock it all off. Well, you may lose granularity that's required. And then below that, you can go into managing it on a bucket-to-bucket basis. But again, you're probably going to want to have some degree of automation there as well, because of making sure that that is properly used, since it's not going to be automatically enforced on everything in the account at that point.
Very good. Very good. Let's hit one that's a little more open-ended, so I'm sure you'll be able to cover this one really well. Do you have any recommendations for account architecture for large organizations?
Yeah, this comes up a
How much time
lot.
do you have?
Yeah, I think we've done an entire webcast on this one ourselves. So the general rule of thumb is that for any given application stack, I like to see dev, test, prod, if you use all three, a logging account so that the people working on it can get to their logs, which can sometimes be combined with the others, and potentially a security account where your security tooling runs out of. Now, some of that, if you have really centralized good management, your logging and your security might be more centralized, although you still want to be able to make sure that the local admins are able to get into the actual logging account themselves, because they need to look at their logs to fix things, even if it's not for security. So that's that rule of thumb. For any given major application stack, break out into those environments, and then have those extra shared services accounts that are available. And I do see this. I mean, some of people listening probably now are like, that is just not possible. It is. I actually used to be, I never saw it. Now I'd say, maybe 30% of the orgs I go into have it set up like that, and a lot have set up at least a designation between production and non-production accounts, and then segregate out by application stacks at that point.
Excellent. Well, we're coming up against our time at the end of the webinar. We want to thank both of you for your richer presentation, and Mike and Rich for your answering some pretty pithy questions, to use Mike's words there. So I want to also announce the winner of our $50 Amazon
Hey,
gift
Rich,
card.
you want to bring up the slides? Yeah, I think there's some contact information.
Oh, yeah,
There
yeah.
we go. Yes,
Switch over.
get that up there.
While Mitchell gives away our little cards, so folks know how to get in touch with us.
The call to action page, if you would bring that up, that'd be great. So the three winners of our Amazon gift cards, drum roll please. First is Ed B, second is Taylor K, and third is Pulkit A. So we'll be getting in contact with you about getting those cards to you. So congratulations to our winners. And just a reminder, we did record the webinar, so we'll be sending that out along with the slides to make that available to everyone, as well as it being on devops.com. And just a reminder, check devops.com too about more exciting webinars that are coming up real soon. So join me in thanking our speakers, both Rich Mogull and Mike Rothman from DisruptOps, and they both also have this other company, Securosis. And we'd like to thank you, our audience, our listeners, for being part of today's webinar. It's been my pleasure to host, and we hope that you have a great day. Be careful out there.